Let's talk about measuring angles using radians. So let's take a look at a circle, and the radius is the measure from the center out to one of the points on the circle itself. And let's say that that radius lies along the initial side of our angle. Now, when we're working with radians, we're actually going to be using the radius of the circle as a way to measure. So kind of think of it as a piece of string, this radius length. We're going to be taking that radius and we're going to lay it along the edge of our circle to measure out 1 radian. So if I take my radius length, start it here at my initial side, and lay it along the edge of that circle, this angle measure then is going to become equivalent to 1 radian. And the nice thing about using radians to measure is that it doesn't matter how big or small our circle is, we're always going to be using that radius length to measure out the angles. Now let's go ahead and tie this back to some degree measures. Keep in mind that when we were talking about degrees, if we did 1 revolution around our circle, that was 360 degrees. When we're working with radians, that's going to be known as 2 pi radians. What if I didn't want a full circle? What if I just wanted half a circle? Well, obviously I could cut this in half, and that's going to give me 180 degrees. If I do the same thing with my radians and cut it in half, half of 2 pi is just going to be pi radians. So let's go ahead and work with this statement. What if I didn't want to know what 180 degrees was? What if I just wanted 1 degree? Then just like we did when we were working with degrees and degrees, minutes, seconds, right, I could take each of these components and divide it by 180 degrees. And so 1 degree is going to be equivalent to pi over 180 radians. And I could do the same thing if I wanted to know the equivalent for 1 radian, right? I could take that same statement that I've been using up here, and I can divide both sides this time by pi, and then that's going to give me 1 radian is going to be equivalent to 180 over pi degrees. Let's go ahead and take a look at a couple examples where we're converting between degrees and radians. And let's go ahead and take a look at this first one. We have 60 degrees, and we want to convert this to a measure in radians. Now, in order to make this conversion, I want to go ahead and multiply it by pi over 180. Because in 1 degree, that was equivalent to pi over 180 radians. So let's go ahead and multiply straight across on this one. That's going to give us 60 pi on top and 180 on the bottom. And we can go ahead and reduce the fraction component piece there, and we're going to end up with pi over 3. If you're someone who's using your graphing calculator and you want to be able to reduce fractions using your graphing calculator, you can do that. Your graphing calculator will reduce fractions for you. When you go to type this in, ignore the pi piece, just work with the fraction component in your numbers. You'll do 60 divided by 180, hit your enter button, it's going to give you some decimal, and then you want to hit your math button, 1, enter. That's going to change it into a fraction for you. You should get 1/3 in that case. Just make sure you put the pi back into your fraction. So 1/3 pi or pi over 3 would be an okay answer for this one. Now keep in mind your 60 degrees here was positive, so this would be an angle that's opening upward if we were to go graph it. The same type of thing should be true for our pi over 3 radians, right? That's a positive angle measure. It should be something that opens upward, and this angle would end up in quadrant 1. Let's go ahead and do negative 45 degrees and convert that one to radians. Okay, I want to go ahead and multiply this by pi over 180. And this one's going to give us negative pi over 4 radians, Keep in mind it's a negative angle measure, so when we're plotting it, we would be coming down from our positive x-axis, and this would be an angle measure that's going to end up in quadrant 4. Let's take a look at converting the other direction. So let's go ahead and take a look at a couple where we are starting with a value in radians, and we want to go ahead and convert them to degrees. So in this first one, we've got pi over 6. When converting these to degrees, you want to multiply by 180 over pi. And kind of like before, when we're multiplying fractions, you'll be multiplying straight across. So I'll do that first before I reduce. That's going to give me 180 pi on top and 6 pi on the bottom. The pi, top and bottom, will cancel each other out, and I can go ahead and do 180 divided by 6 to get my answer. And this one will come out to be a 30-degree angle. It's positive, so it's definitely going to be opening upward, and when we draw the angle, this one should be drawn in quadrant 1. Let's take a look at this next one. We have negative 5 pi over 6. Again, I want to go ahead and multiply this fraction by 180 over pi. This is going to give me negative 900 pi on top, 6 pi on the bottom, and now I can go ahead and reduce this. This is going to give me an angle measure of negative 150 degrees. Keep in mind, if I'm starting that from standard position, this angle is going to be drawn downward and should end up in quadrant 3. And let's do one more example. Let's do 5 radians. We want to know how many degrees are in 5 radians. I'm still going to take this and multiply it by my 180 over pi. So I'm going to get 900 on top, pi on the bottom, and you're going to notice that I don't have a pi on top in order to cancel the one on the bottom out. I can still take this out to a decimal. You're going to type it in just like you see it onto your calculator. It's going to be 900 divided by pi, and you should have a pi button on your calculator. Go ahead and use that instead of using 3.14. I took mine out to 2 decimals, so 5 radians would be equivalent to about 286.47 degrees.